Have you ever touched ice and felt like it burned? It's a curious and unexpected reaction. This strange sensation, a burning feeling from something very cold, is a fascinating puzzle. It challenges our understanding of how we perceive temperature. It showcases the intriguing difference between our perception and reality. Our senses can sometimes deceive us, making us question what we feel. This phenomenon, often referred to as the temperature paradox, reveals the complex ways in which our bodies interact with the world around us. It's a reminder of the intricate design of our sensory system. The feeling of cold is just as much a creation of our minds as it is a physical sensation. Our brain plays a crucial role in interpreting these signals. Our nerves, specifically those designed to sense temperature, are stimulated by extreme temperatures, whether hot or cold. These nerves are incredibly sensitive and can detect even the slightest changes. When these nerves send signals to the brain interprets these signals as pain or discomfort. This is why touching ice can feel like a burn, a testament to the complexity of our sensory experiences. The temperature paradox arises because our bodies don't sense actual temperature. Instead, they sense the rate at which heat is being transferred, which can lead to some surprising sensations. For instance, when you place your hands near a campfire, the rapid transfer of heat to your skin is immediately noticeable. Conversely, when you touch something cold, like ice, the heat is quickly drawn away from your skin. When you touch ice, the rapid transfer of heat away from your skin, due to the ice's low temperature, triggers your nerves to send a signal similar to the one for extreme heat. This can be quite confusing because the sensation of extreme cold can feel like burning. This paradox highlights the limitations of our sensory perception. Our senses are not always reliable indicators of the actual conditions around us. We rely on our senses to understand the world, but our senses can sometimes mislead us. This is especially true in extreme environments where our sensory inputs can be easily tricked. The temperature paradox is a prime example of how our perception of the world is not always an accurate reflection of reality. It reminds us to question and investigate our sensory experiences to better understand the true nature of our surroundings. Our skin, the largest organ in our body, acts as a mediator between the external environment and our internal systems. Specialized nerve endings called thermoreceptors are scattered throughout our skin. These receptors are responsible for detecting changes in temperature. These thermoreceptors come in two main types, those that detect warmth and those that detect cold. When you touch something cold like ice, the cold receptors send signals to your brain, which then interprets these signals as the sensation of coldness. The burning sensation you feel from extreme cold stems from the overstimulation of these cold receptors. These receptors, known as thermoreceptors, are specialized nerve endings in our skin that detect temperature changes. When they are exposed to extreme cold, they become hyperactive. When exposed to very low temperatures, these receptors fire rapidly, sending a barrage of signals to the brain. This rapid firing is a desperate attempt by the body to alert you to the potential danger of frostbite or hypothermia. The brain, overwhelmed by this intense stimulation, interprets it as a burning sensation, similar to what you might feel when touching something hot. This is because the brain uses similar neural pathways to process both extreme cold and extreme heat. The temperature paradox is a fascinating example of how our brains interpret sensory information. It shows that our sensory experiences are not always straightforward and can sometimes be counterintuitive. It teaches us that our perception of the world is a complex process, influenced by both physical stimuli and our brain's interpretation of those stimuli. Our brains are constantly working to make sense of the signals they receive, sometimes leading to surprising results. So the next time you touch ice and feel a burning sensation, remember that it's not just the ice you're feeling, but your brain's interpretation of the extreme cold. This remarkable process is a testament to the complexity and sophistication of our nervous system.